What's up guys, welcome to another video, and today we will be going over 3 downsides to research and development. I worked in the research and development field for a couple of years ago, and I'm a mechanical engineer, by the way, for those of you who don't know anything about me. I've been in the field for approximately 10 years. And so I'm going to give you some insight here. And this video is not meant to discourage you. It's not meant to tell you, hey, do not get into research and development, because it's a cool field. You get to do great things with other people's money. But there are some things that you need to be aware of, so you know what to expect and you can overcome the challenges that may be coming your way. But hey, if you do not know, if you do not have a background on research and development or what it is, here I'm going to give you a very quick background. If you're watching this video, most likely you already know what it is. But hey, I'm just going to give you a very quick rundown of what research and development is when it comes to us engineers. And when it comes to R&D, it's the field where engineers research and execute tests on product ideas, develop new products, and perform redesigns, optimization. In many industries, mind you, it's not just for mechanical, it's not just for electrical, it's for manufacturing and pharmaceuticals, consumer goods, and military, in tech, even in social media. If you think about YouTube, if you think about Instagram, if you think about TikTok, these software are always improving. They're always looking to make ways more addicted to these social platforms. And so that's the research and development that is being done by the tech engineers out in Silicon Valley. And so when it comes to general duties for a research and development engineer, so there's basically two different levels as far as I see it, based on my experience. You have the engineers that are doing the design, the engineers that are doing the grunt work, the engineers that are doing the optimization, the hands-on, the calculations, and all the modeling, the AutoCAD. But you also have the project lead, you have the project manager, the one that manages the schedule, the one that is worried about designing the project plans and collaborate with other departments. Because when you do research and development, for example, I was a mechanical engineer, and as a mechanical engineer, I was dealing with a lot of electrical engineers, a lot of software people, software engineers. And so it's not just that you're going to be working in a vacuum. It's about you collaborating and working with other engineers as well. So continuing with the background here, I'm going to give you some examples so that you get a better idea of what I'm referring to. So if you think of the iPhone, right? The iPhone has been through dramatic changes. Well, not many dramatic changes since it started back in the day. But hey, if you look at the software, if you look at the hardware, these are the things that engineers are constantly improving. They're constantly researching and they're constantly developing. The software is faster. The hardware obviously gets improved. You get more data transmission, and I hope that I am saying the right things here because I'm not a software engineer. But hey, when it comes to the Tesla truck, let's talk about that for a second for me, a mechanical engineer. Of course, when it comes to the Tesla truck, it's something that hasn't been released by Tesla yet, but we know that it's obviously going through research and development because you're going to have a battery that is going to be optimized, a battery that is going to be improved. Of course, you also have to worry about the structure, the material that is being used in the truck, the suspension. When it comes to aircraft, what are the things that get improved? Of course, we're talking about the engines, the turbines. We're talking about the wings, the landing gear, the materials that are used to build airplanes. For example, one of the things that I realized, or not that I realized, but something that I realized for the first time when I was in school, is that airplanes nowadays are implementing more and more carbon fiber. Back in the day, they used aluminum, and now they're actually using more lighter materials to make things more efficient and overall save money. And when it comes to regular cars, of course, we're talking about better engines, more fuel-efficient engines. That's a result and an outcome of research and development and making things better. And now we're not just talking about physical things, physical products, but also processes where our friends, the systems engineers, come in and start making things more efficient, optimizing processes. In other words, to save money, cost. And so the one thing that I want to mention here is that R&D is a cool field, but there are some downsides that you need to be aware of, because you don't want to get in a field and you want to say, hey, I don't know, I just got laid off. So these are just some things to keep in mind of. And so the first thing that I want to say here is that when it comes to research and development, it may not be too easy to get into, and you may need strict qualification requirements such as citizenship or security clearance. And if you ever work in military in the United States, if you support the military one way or another, you're definitely going to need some clearance. and that basically means a process that people or the government looks into your background, and they make sure that you are someone that is not likely to take the technology that you're developing and the optimizations, the processes, designs, and you're gonna give it to somebody else. Now, of course, companies also do this. They want to make sure that you're not giving the company secrets to a competitor, or even, hey, you may even take that technology and use it yourself. So they want to make sure that you go through the process. And if you do, there will be consequences. So the reasons why they do that, number one, of course, we have the intellectual property. Number two, there's also secret developments for companies and countries, as I just mentioned. And for that, you need to sign non-disclosure agreements. You also need to get a clearance. And so that's basically how it may not be too easy to get into when it comes to research and development. Okay, so when it comes to the second downside of research and development is that it can be stressful, and it can be very stressful. And that's for many reasons. It can be because, hey, you will have a deadline next week and you have a ton of work to do, and the client and the people that are basically paying for the project, they require you to submit something at that day. You have to meet the requirements. You are not sure whether or not the design or what you're developing is gonna do what it's supposed to do. And on top of all that, you're already way over budget, you're overspending. And so there's a lot of pressure and there's a lot of stress that can go into research and development, depending on the client, depending on what you're building, depending on the size of your project. So it's not like you're just gonna go chillax and you're just gonna be building things and just blowing things up just for fun. You know, I remember a couple of years ago when I was doing research and development, I was working with an engineer who was the lead. He was the project manager for all the electrical engineers that were manufacturing this piece of electrical equipment. And he was under so much stress. He was over budget. He was not meeting deadlines. And because I was in contact with him almost on a daily basis, it wasn't so much because he was messing up. It was just because of things outside of his control. Many times, he would progress with the manufacturing process of this electrical component, and he would find things that were not done properly. Sometimes he would get parts that he needed to build what he was building. He was dealing with other outside vendors, third parties, and sometimes the parts that he would receive were not built up to spec. Sometimes the vendors would send parts that were late or that were not done properly. And so when it comes to research and development, it's not that you work in a vacuum again. You work with other engineers and other departments, other vendors, other manufacturers. And in order to make things work, there's a lot of things that have to come into play. And so really at the end of the day, communicate the issues and then just work as a team on what can be done and focusing on what you can control, and then try to mitigate other issues that may show up in the future. Okay, so when it comes to the third downside of research and development is that the work can be unexpectedly cut or finished, which may lead to layoffs. And this is an unfortunately part of the industry. And I want to say that any engineering industry for that matter, or any industry overall. And that's because sometimes clients realize that, hey, something is going to be too expensive, or they realize that something cannot be done physically. The physics is just not working. It's unrealistic. And so as the project goes on and the design goes on, the development continues, and the engineers start finding problems, the engineers are going to start requesting more money to do more testing, more research. And then me so let's say I'm funding a project, I'm developing a new aircraft. And if I say, you know what, I only have $100 to develop this aircraft, and the engineers I've already spent $90 out of the budget, and there's all this work to be done. So me, with a limit in my budget of $100, I can say, you know what, I don't think this is going to work for me. I'm going to have to cut it. And so if the project stops right there and I bail out as the customer, as someone that's paying for that project, all the engineers that are working on the project, they're suddenly jobless. And so that's something that you need to be aware of. And I would definitely ask what kind of project somebody's working on. Now, if you get into R&D and you actually work for an entity or organization that is stable, if you work for the customer, then I think it can be a little safer. But if you are actually the one that is getting funded, that's getting funding, then I would definitely be more cautious about the R&D position that you're getting into. For example, one of the things that I was reading up on is the military F-35 aircraft. And a lot of people were arguing that this project needs to be cut, and that's because they realized it was getting too expensive, and hey, they were trying to make this aircraft do too many things, and it was just getting to be too much. So now, if the project gets finished, then what do you think is going to happen with all of the engineers and all the vendors and all the manufacturers that were supporting this project? They're just going to be out of a job. And that's unfortunate, but it's something that happens. And at the end of the day, it's a business decision saying this is too expensive. The same thing can happen if you are working for a startup, or if you're working for a new software company that realizes, hey, you know what? This app is getting too expensive. We don't think it's going to work. The benefit doesn't outweigh the cost. And so people just cut it. The company vanishes, and you have all these engineers that are laid off. So although research and development can be a good field, I just show you 3 downsides that are not deal breakers in my personal opinion, but I think are things that you need to be aware of, and something that not expect, but at least know can happen, so that you know what you're up against. Now, if you want to get into this field, which is a really cool one in my personal opinion, you can watch this video right here where I tell you how you can get into R&D and get yourself a job. All right, guys, I'll see you there. Peace.